Okay, part 2 of making a compiler. Got some coffee this time. So if you haven't watched the previous video, go do that if you want to. And okay, let's start. What we did in the previous video was that we wrote our lexer basically. So if we run this, we're able to generate some tokens from this source code here. And the language we're trying to compile is my own sort of language that is inspired by TypeScript and C, and it's also going to have some inspiration from assembly actually, but we'll get to that later. But this is what the main function would look like in this language. Anyway, so where we left off before was in the parser. We were starting the work on the parser. So one thing we need before we can continue with the parser is some sort of dynamic array where we can push items to. So I'm just going to create a list.age def tag list age define tag list age, and if type def struct list struct list t, and we're going to do a void items size t items. No, let's just call it size, and we're going to need just to be lib.h, I think. Okay, and then we're going to have a list t init list. Actually, let's do this too. Size t item size, and it's just going to take in a size t item size. Okay, and then in our we need a list.c file as well. Okay, and then we're going to do list t list is equal to calc one size of struct list struct list size is equal to 0, list item size is equal to item size, list items is equal to 0. We don't really need to do that since we're using calc, but who cares? Return list. And we're actually also going to want void list push list t list and an item void item. So that we can push items to this. So basically we're going to do if not list items. Actually, first we need to list size plus equals 1, and if not list items, then we're going to do list items is equal to calc 1 list item size. Otherwise, list items is equal to realloc list items list item size plus no, list size times list item size. Okay, and then we can do list items list size is equal to item. That should do it. Cool. So now what we can do is basically in our AST, we're going to include list.age, and we're going to do a we're going to have a list here. So let's just call it I don't know, list.t children, and in our ast.c we're going to do if type is equal to ast compound. We're going to do ast list ast children is equal to init list size of struct ast struct pointer. So are you happy about that? Not really. ast, so you don't know what a compound is. Oh, comp so we only want to initialize the list if it's a compound. And now in our parser we can actually create this compound, and we can push this to it. So we can do list push compound children child, and we might we could just do this, right? And then we're going to return the compound. So now in our tag.c, let's just print root like we did before. So printf p root. So we're getting that root node here, which is going to be that compound. We might even do let's print the size of it. And we're getting a sig fault for some reason. Where are we getting a sig fault? Where are we getting a sig fault? Parse. Oh. So here we need to do return parser parse compound. Parser. Okay. So wait, is this really what we want? I don't know. Parser parse compound. So now we're still getting a seg fault for some reason. Let's just see why that happens, I guess. So where are you? Doesn't really tell me where it's happening, but what if it's happening here? Return compound. Oh, so this is actually reaching a we're getting an infinite loop here basically. So parser parse compound. Wait, do we really want to parse a compound here? I have to think a little bit. Parsing the compound, parsing the compound, parsing the compound, parsing the compound. I think we might actually want a switch here instead. Yeah, we actually, or do we want a switch here? We want it to parse a expression, right? So the parser is parsing a compound always, but it's going to, we're ending up in an infinite loop here actually, which is understandable. So we're going to do a parse expression instead, parse expression, and we're going to do a stt parser parse expression parser t parser. Parse expression. And here we will do a I don't really like that though. Parser parse compound parse expression. Actually, parse compound, parse compound. Let's just go with that. Okay, so then we're going to do a switch parser token type case token token ID. Then we're going to do a return parser parse ID parser, and we're going to do stt parser parse ID parser t parser, and we're going to do a parser e parser token ID, and then let's just add a default here for now. So default parser unexpected token printf token to stir parser token, and exit one. So we're reaching an ID. So we're parsed it, so we can do char value is equal to is equal to parser token value. We might calc it actually, calc. Sharp +1 and source key value parser token value include string.h. So now we have that value. F value. Let's just see if we have. If we got it, yeah. So we're getting the main token here. Cool. So we have successfully parsed the main token here. So we're also going to have a basically this is where this function here is going to branch out. So if a parser token type is equal to token equals parse assignment else parse variable. So we would do a ast is equal to ast variable ast. Now we need to add a name here, so we're going to do sharp name parser is equal to value, and yeah, that's it. And then if we have an equal sign, we're going to do a actually we're going to return ast here. If we have an equal sign, then we're going to do ast is equal to init ast alignment. Do we have that? Let's actually call this function instead, and then we're going to do an ast assignment, and then we can do ast name is equal to value, and then we're actually going to add another field here called struct ast struct. Let's call it just value. And we're going to do ast value is equal to parse expression and return the ast. We don't actually need this else here. So we should end up here now. So printf ast name. So we're getting an assignment, okay. Unexpected token equals. Oh, that's because we need to eat the equals as well. So parser token ID, token equals. So now we're getting the left parentheses. Cool. So now we actually need to, we're going to do a token lparent, return parser parse list. That's going to be a list, okay? Parse list to parse list. So Okay, we can basically copy this. And we could just treat that, we can just use the compound again. So but we will switch this to while parser token type is equal to token comma. Yeah, that sounds right. That sounds right. Token comma. So basically we also want to do this. We're going to do that. And then we're going to do parser parser token comma. Okay. And actually we need to do parser parser token parent. And then when we're done, we're going to eat that as well. So parser right parent. Okay, let's see where we end up now. So now we're getting that. We're getting unexpected token int. So basically the the variable here, after we have parsed it, it's actually going to try and parse a comma. So I think if we do like and we'll do we're just going to check if parser token type is equal to token colon. I think that's going to be, no, it's not true. So what if we do token to string parser token ID int. So the colon has been parsed. I don't get. Parse ID. So what's actually going on here? It's skipping the colon? Is it skipping the colon? What if we print the name here instead? argc. So we have parsed the argc, but why is it? Oh wait, I think there's a problem with the Lexer actually. So when we're parsing the ID, we don't really need to. We don't need to do this actually. So now we're getting the colon here. So that's good. That's good. So basically, now we also need a some way to store the type here. So I think we can just do int data type, maybe. So then we can do then we can just do if parser token type is equal to token colon, then we can do parser token colon, and now we have the data type, so we can do AST type, data type is equal to parser token type, and then we can actually add another ID. So now we're getting the less than sign. So I don't know how we're going to do this. So if we're getting a less than sign, oh, actually, I know how to do this. So I think we can do this. So we don't want to parse. We don't want to parse an ID directly. We want to do a if parser token type is equal to token less than, then we want to add a less than, and then we're going to parse an ID, and then we're going to parse a greater than. So actually, this is not good. I wonder if there's a way to okay, I know what we can do. So we're going to do this. Utils. Maybe we can just call this types.h. If def tag types h, define tag types h, and if, and we're basically going to do a int type name to int const char name. And this is going to be a little hack, I guess. Include /types.h, and what we're going to do is basically int t is equal to 0, and we're going to do size t strlen len is equal to strlen name include string.h. And then we can do for int I is equal to 0 if I is less than len I plus plus. And we can basically do t plus equals name I, return t. That would basically give us a unique integer for each type. So now in our parser, we could do include /types.h, and then we can do type name to int, and then we can do So if it's a colon, actually this is, so what are we seeing here? Okay, I know what I know what we're gonna do. So while parser token type is equal to token ID, est data type plus equals this, and then we're going to do that. And so what's really going on here is while we have an ID, we're going to parse, we're going to eat the ID. Okay, and then if we have a less than sign, we're going to do the less than sign. And then we're going to do that, and we're going to expect another ID. And we're going to then be greater than sign. Unexpected token colon. Colon. So we're still getting a colon. Are we even ending up here? That's a big question. So yeah, we're ending up there. Then we're eating the less than sign. And then we're less than sign. Okay, so what do we have here? Printf token to string parser token greater than. Yeah, we do have a greater than. That's great. Parentheses. Oh, I know why. So actually, we're done parsing here now. But what we actually this does, we can just do this here. Okay, so now we have parsed the ID, and we have actually done parsing the list here. I think we're actually ending up here. Printf. Yes. Yes, we are. So now we actually have a colon here. So basically we're going to do the same type of thing here. basically. So compound. Let's just call this AST instead. So now it doesn't know what to do with the right arrow. So okay, but we're basically in an assignment here. Equals. So now we could do parse expression. So basically here we want to do so this is going to be equal to a list. That's right. And the list. Yeah, actually, if this list comes with an arrow, if this comes with an arrow, then it's actually a function. So basically, if parser token type is equal to token arrow right, then we're going to change this type. So AST type is equal to AST function instead. And then we need to parse the function body. So first, of course, we can eat this arrow right. That should be the first thing we do. Token arrow right. And now we need a function body. So what we can do here is basically struct, AST struct. If we could just, we could actually use the value here. So the value is going to be the body. So AST, actually we want to do, so basically if we could do a compound here. So actually, let's do it like this. AST value is equal to parse block. And that's what we're going to do. So now we just need to add that function. STT parser parse block parser t parser, and you're going to expect a token brace, and then we're going to do a while we can actually copy the compound thing. Compound. while parser token type is equal to token semi. Or should we do that or not? No, actually, while parser token type not equals to token right brace, then we can do list push st. Let's call it ast. Ast children parser parse expression parser. Okay. And then parser token right brace. Return ast. So now we have the parse expression, we have the parse list, and you're parsing a block here. Okay, cool. Unexpected token greater than aren't you an arrow? Token left brace. Aren't you an arrow? Oh wait, so in the Lexer, when we're doing this thing, we need to advance twice, so unexpected token type int. So now it's actually reaching the 0 here. It has already parsed these this return here. So so when we're parsing now ID, if token is colon, maybe we should just treat that as a, I don't know, it's going to be a statement, isn't it? So if else, if parser token type is equal to else if parser token type is equal to st int st. No, I don't like that. I don't like that. How will I do that? Parse ID. Maybe we could just do I don't like statements. I don't like statements like that. What if we always had returns as a function call? What if we always had returns as a function call? Yeah, I think we're going to do that because I like that better. So we're going to have a ast call. And then in our parser, we're going to do if parser token type is equal to ASTL parent, then AST type is equal to AST call, and then we're going to do we're going to have to parse a list. So the call is going to have some children is equal to parser parse list parser. I think that might work. Parse list. So the list parse list function is put it in a header file. Let's have some coffee. Okay. So we're still all right because it doesn't know what to do with that. So in the parse expression, we need to do case token int return parser parse int parser and stt parser parse int parser t parser. We're going to do int value is equal to y parser token value, and we're going to do parser parser token and ast ast is equal to ast int value is equal to int value return ast. Now we have to also add this here, so we're going to do int value ast int. Okay, so are you happy now? No. Parse list children. Oh, we can't do that. Okay, so parse list. Where did we do that? Parse list. Here, of course, you have to do value. Value is equal to parse list. So the ID. Children. Okay, so you're going to have a list as a value, which is okay, I guess. Okay, 72 should be a token. Token semi. I think we're getting that here. So if parser token type is equal to token semi parser e parser token semi. Right parent. Are you kidding me? Oh, I think we have a problem here. So it's the lecture again. Unexpected token semi. Oh, it's because brace, left brace, now right brace. Now I think we can actually use this here instead. So in the parse block we can just do parse compound. Token left brace. Oh right, because it doesn't know. So basically what we have to do is if parser token type is equal to token left brace, parser e, parser token left brace, and we could also do this then unsigned and should close is equal to 0 and should close is equal to 1, and then we could do if should close parser e parser token right brace, and there we go. It actually works now. So the reason why it's printing a 1 is because in our tag.c I'm printing this size here. So we have successfully parsed all of the stuff. So parse compound. Let's just see how many times we end up in this loop here. 2 times, does that make sense? 2 times, yeah, that makes sense. So I think we have successfully parsed that whole tree, or that whole source code. So the next part is to convert that to assembly, basically. So the way we could do that is, let's call this assembly front end. Def tac as front end, tac as front end, and then we could do void f I think we can do that. That seems good. And then we would have to include slash ast.h, and we would do astt ast. Sorry. And then we would basically have some coffee. And copy this, and we would do a touch front end.c. And then we would have a switch here basically. So we would have a switch AST type case AST compound. Then we would do actually this is going to be a char. Okay. Char value into the calc one size of char. And then we would basically do char next value is equal to 0. And then we could do next value is equal to ASF compound. And then we do value is equal to realloc Sterling next value plus 1 value size of sharp and return value and string cat next value into value. To include include string.h and STF compound. And then we'd have a case case EST compound function variable assignment. Variable is call and we would also have a default front end for Steve type. stio.h, and then you would basically have char ASF compound assignment call and so here's basically where we would convert or compile everything down to assembly. So this would be included in here. So we would do include slash is frontend.h, and we would do, instead of this thing, we would do char s is equal to asf root, and then we could do printf s. So this will not do anything right now, but here in the compound, we would basically do for int I is equal to 0 if I is less than st children size I plus plus, and then we would do this type of thing. And char next value is equal to asf stt child ast is equal to ast children items I, and we would do child ast, and then we would return the value. Okay. And now we're actually getting a seg fault for some reason. I think it's because this actually returns a 0. So if we would do a that still gives us seems to happen when we call that function. So why is that happening? What are you? Printf child ast type. So like you are you're null? Are you null? So for some reason, he is null. Why are you null? So when we're parsing the compound, what are we getting here? What? Parser, printf. Why are you null? I don't get why it's null. So maybe it's something wrong here. Oh, -1. no, now it's no longer null. So that's good. So now, for example, if we do in the assignment here, for example, if we would do char s is equal to calc Sterling example char. I kind of would have expected an assignment here. So we are getting there, but you're not getting what? Why are you not working? Oh, I know it. I know why it's not working. It's because we need to do string cap value next value. So now we're getting that. So obviously this is wrong here, but you get the point. So in here we're going to convert everything to assembly. I realized we're gonna have to add some sort of state to this front end so that we can put make sure that things get put in the right sections in the assembly code. But this is it's a good start, I guess. So that's it for this video. Hopefully in the next video we'll get some assembly working here. Thank you for watching.